Today's practice is on integral by parts. So find the integral of the given functions below by using integral by parts techniques and show complete and logical work. So integral by parts, some of you may know already, but it's basically when two different functions are multiplied to each other, and then we can't use other formulas like U substitution, trigonometric integration. Those techniques are not able to be used. Obviously, you can see that we can't really sub in x to the third to like anything else like ln x to make it a U substitution. It's not possible. So there is no given or known way until this point to solve this question, but then integral by parts will be used to solve this one. So just simplified way, integral by parts is when you're multiplying two different functions, and then it can't be derived, or you can't take the integral of it any other way. Okay, and then the formula would be like you would have to divide the function into two parts, like I said. So that's why it's integral by parts. And then you would define one as u and the other as dv. And then you would have to take the derivative of. So u equals blah, and then you have to find a du equals blah dx. And then dv, you have to set something as dv. And then you're taking the integral of it to get the v value. And then from here, you're going to do u times v minus v and then du. So this is the integral by parts formula. So let's say that, I don't know, let's just say that our u is x to the third, du is, obviously like derivative of that would be 3x to the second power, and then don't forget the dx at the end. And then dv, you can set it as ln x, but then v, the integral of ln x. So we don't know the integral of ln x, right? So that's why we need to switch this around. So make sure that if you're setting dv as something, that you can definitely take the integral of that to give a known value. So if you can't find the integral of a certain function, then that's probably a sign that that should be taking the derivative of instead of the integral of. Okay, so we're going to switch around. Okay, and then we're just going to say u equals ln x, because we already know the derivative of ln x, and then so dv would be x to the third power. So du equals 1 over x dx, which is the derivative of ln x, and then v is the integral of x to the third power, which means 1/4 x to the fourth power. So this would be our basic, I guess, organization before we start our integral. So we can now say that u times v, which is ln x over 4, we'll just do 4 to the x to the fourth here, and then minus v du. So we can say 1/4 x to the fourth, okay, and then times 1 over x, and then dx. So here's a lot. We're just gonna say x to the fourth ln x over 4 minus 1/4 comes out, and then x to the fourth over x is just x to the third, and then dx. So here we can see that our integral is able to be simplified. So let's do one more step. X to the fourth ln x over 4 minus 1/4, and then integral of x to the third would be 1/4 comes out, and then x to the fourth power plus c. So our answer would actually be x to the fourth ln x over 4 minus 1 over 16 x to the fourth plus c. So this would be our answer for number 1. Okay, number 2. So number 2 seems a little bit more complicated, but essentially this can be simplified into integral of e to the negative x sine x dx, right? Because this is at the bottom, so it's essentially e to the x to the negative 1 power, which just means e to the negative x power. Okay, so that's that. And then now we made it into a, I guess, more typical integral by parts form. And then let's just see. e to the negative x and sine x. So we don't really know what to make our u and dv. So in this case, there is actually, I guess, a known way that we can figure out which one u should be. So there's something called LIATE. So L stands for logarithmic, log, so it's just like log or ln, those things. And then I stands for inverse, so inverse. And then A stands for algebraic, and then T stands for trig, and then finally E stands for exponential. So these things are pretty self-explanatory. So trig, like sine x, and then exponential is like e to the x, and algebraic is more like polynomials, y equals x to the third, like those things. Inverse is pretty self-explanatory as well. So this is the order. So it goes from top to bottom. So whatever comes first. If you have for example, since we have number 2 here, since we have both exponential and trig, and then we see that trig or t is higher than e. So that means that t should be, or trig should be, our u value, and then e should be our dv value. So this is the order of importance, or like just the primary things to determine what u value should be for you. Okay, so top to bottom, remember that, don't do the other way. Okay, so now that we know this, we're just going to set u as our trig, which is sine x, and du would be cosine x, dx, and then dv would be e to the negative x. So v would be the integral of that, which means it would be negative e to the negative x. So that's our v value. And then now let's find the integral by parts. So first, u times v, which means negative e to the negative x times sine x, and then minus, and then we see that the v value has a negative in front of it. So we're just going to take it out, and then combined with the negative already there, it's going to be a positive value. And then e to the negative x times du, which is cosine x dx. Okay, so we see that it's like a similar form, right? It's just changed from sine x to cosine x. So now we have to take this one more time to see where it leads. U equals e to the negative x. We're just gonna use the same variable again. Don't be confused here. And then, oh, never mind, not u. It's gonna be cosine x du. So derivative of cosine x is negative sine x dx, and then dv would be e to the negative x, or v is negative e to the negative x, just like we did before. Okay, and then negative e to the negative x sine x, and then we're going to take the integral by parts of this function. So it's going to be, let's make a huge square bracket. So u times v is negative e to the negative x cosine x, and then v du. So negative, and then negative e, and then negative sine x, so it's going to be cancelled out to positive. So our negative sign already here would just stay a negative instead of positive. And then e to the negative x, and then sine x dx. So we see now that it just returned back to the original, right? One sec. Okay, return back to the original. So you might be confused, like, am I stuck in this loop forever? What is going on? So let's just go back and say that this itself is a function. It's like f of x or y. So it's like y equals integral of sine x over e to the x dx. And then because like we're trying to simplify the situation, we just didn't include y equals, but originally there was a y equals. So this is a function itself. So we can just say that this is y equals integral of sine x over e to the x dx, right? Okay, so on the other side of this equal sign, there was always a y, but then we know that y is equal to the integral of e to the negative x times sine x dx, right? So this whole thing right here is equal to integral of e to the negative x sine x dx, all right? Okay, and then, so that means that this like term can be moved to the other side so that they can be combined, and then we can find the answer to the integral. All right, so equals negative e to the negative x sine x, and then negative e to the negative x cosine x, and then minus a to the sine x dx, okay? And then that's equal to e to the negative x sine x dx itself. So let's try to move this to this side so that we can combine the like terms, and then we will get 2 times integral of e to the negative x sine x dx, right? And that's equal to negative e to the negative x sine x negative e negative x cosine x, okay? And then to find the answer to this question, which is this, which is the same thing as this as well, we're just going to divide each side by 2. So integral of e to the negative x sine x dx equals negative e to the negative x sine x minus e to the negative x cosine x over 2. Okay, so this would be our answer right here. It's a little bit more complicated, but once you get it, I think you'll get it. Okay. Now we have this one, ln x and then power of 2. So this might seem a little bit confusing to you because, like I mentioned earlier, usually there are two functions multiplied to each other that we can't solve using u substitution or other methods, and that's why we resort to integral by parts. But now we see that we don't have two functions multiplied to each other. So that's kind of confusing, but then if you just see, you can kind of tell that there's nothing you can really do, like no u substitution, no trig integration, no other methods, like no partial fraction that you can do to decompose this. So you might just have to resort to integral by parts here, right? And then according to our LIATE, log comes first in the order, right? So that means that we're going to set the log as our u. We're just going to set it as u equals ln x to the power of 2. And then du would equal to derivative of that, which means 2 times ln x. And then derivative of ln x is 1 over x. So that means 2 ln x over x would be our du. Obviously, include the dx, don't forget it like me. So it's going to be that. And then dv now would just equal dx. It's basically 1 times dx, so that could be our second function if you really want to call it that. So just think of it as this. So this is our dv, or d's are dv, and then these would be our u, okay? Alright, and then v would just be x, right? Okay, and then now we're going to go into our form. So uv minus v du, integral v du. So, okay, and then what's u? U is ln x to the power of 2. So ln x to the power of 2 multiplied by v, which is x. And then minus v and then du, which means x times 2 ln x over x dx. So we can cancel out the x's here. That means x ln x to the power of 2 minus integral of 2 ln x dx. Okay, so that is x ln x over 2 minus 2 comes to the outside, and then ln x dx. But here we know that we don't really know the integral of ln x dx, right? So I guess we have to take the integral of this one more time. We have to do integral by parts one more time. One thing that could kind of help you out is that if you compare your integral by parts result to your original one, integral function, if it's much simpler than that one, then that means you're on the right track. But then if it's more complicated than the original, then that probably means that you did something wrong. Maybe you should do another method. You should switch around your u's or dv's. So just consider that. This is like a checkpoint. And we see that before it was ln x to the power of 2, but now it's ln x. So it's much simpler. So that probably means you're on the right track. So just trust the process and take the integral by parts one more time. Okay, we're gonna get rid of this line, random line. Okay, equals x ln x to the power of 2 and then minus 2. And then once again, we're going to take this one more time, but we're just going to use the same variable so don't get confused. U equals ln x again. Du is 1 over x. dv is dx. 1 times dx. V is just x, right? Alright, and then we're going to do a huge square bracket here. And then uv is x ln x minus x times du would be integral of, this just cancels out, so it would just be dx, 1 times dx. Okay, so now this is much more solvable, right? Which is equal to x ln x to the power of 2 minus 2x ln x, and then integral of 1 is just x, right? But then it has negative in front of it, so negative x, but then we also have negative 2 outside of parentheses, so that means plus 2x plus c would be our answer. Also, just going back, let's make sure that we put a c here too. A c is essential for integrals.